So this is the 16th video on kinetic friction. Okay. In this video also I'll take up a numerical problem on friction. First what I'll do, I'll draw the diagram of the situation and state what we have to calculate. Then I'll outline the various steps to be taken to solve the question, and then I'll finally solve the problem. Okay. First I draw the diagram of the situation. Consider the diagram shown below in which all the details are given. Okay. Diagram I draw on the second column. Okay. The diagram is this. There is a rough horizontal surface. A wedge W of mass 3m is placed on this rough surface. There is a pulley which is attached to the wedge by means of a light rigid rod. Here there is a fixed vertical wall. Here there is a string which passes over this pulley and passes over two more pulleys like this. And here there is another block of mass m. Okay. This block of mass m is denoted by capital V and wedge is denoted by W. Friction coefficient between wedge and the rough horizontal surface is 2 mu. Friction coefficient between block of B and wedge W is mu. The string is massless and inextensible, and there is no friction between string and the pulley in contact anywhere. Okay. String is massless and inextensible, and there is no friction between string and the pulley in contact anywhere. Okay. And the pulleys have been numbered: pulley P1, pulley P2, pulley P3, and then block B of mass m and wedge W of mass 3m. Okay. Question is, when the system is released from rest, find the acceleration of 3m with respect to ground. This is the question. So, when the system is released from rest, 3m will move with respect to ground in rightward direction with some acceleration a which we have to determine. And with respect to wedge, the block B will move in downward direction b, acceleration b with respect to wedge. So, small b is the acceleration of block B with respect to wedge. ACCN meaning acceleration. W for wedge, and A is the acceleration of wedge with respect to ground, AWG. AWG meaning what? Acceleration of wedge W with respect to ground, that is AWG, which is just A. So now we have to determine this quantity A. A we have to determine, okay. Answer should be in terms of mu and G only. Answer should be in terms of mu and G only. Fine. A should be in terms of mu and G. Okay. So first of all, what I do, I have shown the required accelerations. Now string is massless and there is no friction between string and pulley in contact anywhere. So tension at all points of the same string is same, say equal to T. T is the tension at all points of this string. Okay. Now see, what I'll do first, I'll set up the constraint relation. I'll find out the relation between B and A. Fine. Then I will apply Newton's second law to block B with respect to ground in downward direction. And then I'll set up the combined equation of motion of wedge plus block in rightward direction and solve the resulting equations to get the required answer. Alright, fine. Now I rub this one. So first what I do, I write down the constraint relation between B and A. We have to find the relationship between B and A. And what is the rule for finding the relation between B and A? Relation between B and A is this: to find the relation between A and B, we use the following rule: summation over Ti dot Ai is 0. where summation is to be taken over, that is sum of T dot A on different points of the bodies on which the string exerts force. T1 T dot AY is equal to 0. This is the rule for finding the constraint relation, where summation is to be taken over all the different points of different bodies with which the string is in contact. Alright. First of all, we see with the string we see with which material bodies the string is in contact. String is in contact with wedge W at this point, say 1. Then string is in contact with quarter portion of pulley P1, quarter meaning 1/4. Then string is in contact with quarter portion of pulley P2. Then string is in contact with quarter portion of pulley P3. Then string is in contact with this block B at its highest point. So these are the different bodies with which the string is in physical contact. Now we have to tell what are the different points of the different bodies on which the string effectively exerts force. Okay, fine. So for that what I do, first I rub it, okay. First I take this, see, string is in contact with block wedge W at this point, let's call it at 1. So I draw the diagram here. I am not drawing the complete wedge, I am just drawing a part of it. This point 1 of the wedge, T acts at this point in rightward direction. Okay, fine. Now I take this pulley P1. I draw that diagram bigger here, just for clarity. Okay. So this is the pulley P1. String is in contact with pulley P1 over its quarter portion, like this. This is the 2 is the lowest material point of pulley P1 which is in contact with the string. And 3 is the rightmost material point of pulley P1 which is in contact with the string. Okay. The string effectively exerts force on this pulley at points 2 and 3. I'll repeat it again. String effectively exerts force on pulley P1 at these 2 points 2 and 3. It exerts a force T on this point 2 in leftward direction and exerts a force T on point 3 in upward direction. So this string exerts force on this pulley P1 at effectively 2 points 2 and 3. At point 2 T left, at point 3 T up. Okay. Now take this pulley P2. Now when string is in contact with quarter portion of pulley P2, alright, string is in contact with the quarter portion of pulley P2, alright. So now I draw that diagram here also, I redraw it. So now this is the string which is in contact with quarter portion of pulley P3. Now 4 is the rightmost material point of pulley P2 which is in contact with the string, and 5 is the highest material point of pulley P2 which is in contact with the string. Okay. Now at this point 4, the string exerts a force T in downward direction, and at point 5, string exerts a force T in leftward direction. Alright. Now I take this pulley P3. That also I draw it bigger diagram just for clarity. This pulley P3. Now string is in contact with quarter portion of pulley P3. Okay. String is in contact with quarter portion of what? Pulley P3. Now I call this point as 6 and this point as 7. 6 is the highest material point of pulley P3 which is in contact with the string, and 7 is the leftmost material point of pulley P3 which is in contact with the string. Okay. Now string exerts force on this pulley at effectively point 6 and 7. At point C it exerts a T rightward force, and string exerts a force T at point C in downward direction. Okay. And finally take the block of mass N. Now string is in contact with block B at this point, say 8, where it exerts a force T on this block in upward direction. So these are the 8 different points on which the string exerts force on the different bodies of the problem. Okay, fine. Now what I do, I rub this one. Okay, fine. So now constraint relation will be this: T1 dot A1 plus T2 dot A2 plus T3 dot A3 plus T4 dot A4 plus T5 dot A5 plus T6 dot A6 plus T7 dot A7 plus T8 plus 8 equal to 0. Now we are setting up the constraint relation in the frame of wedge. So all these A1, A2, A3, they are all the accelerations of the numbered points with respect to wedge. And T1, T2, T3 are the tensions acting at these points. Okay. Now we add all of them and equate to 0, we get the relation between B and A. Now take this first case for T1 dot A1. At point 1, T1 is T, right? A1 is acceleration of point 1 with respect to wedge, which is 0. So T right into 0 becomes 0. First term T1 dot A1 becomes 0. Now T2 dot A2. T2 dot A2. Now see this point A2. At this point T2 T2 is T left. T2 is equal to T2 acting at point A2 is T left. And acceleration of this point 2 with respect to wedge, that is A2. Now with respect to ground, wedge is accelerating rightward. And with respect to ground, pulley P1 is at rest. So with respect to wedge, acceleration of point A2 with respect to wedge is simply A left. And at point 2, T2 is T left. And acceleration of point 2 with respect to wedge is A left. If you take the dot product, it becomes T into A into cos 0 degree. Cos 0 degree becomes 1. Plus. Now T3 dot A3. At point 3, T acts upward. T3 is equal to T up. And A3 is acceleration of point 3 of pulley with respect to wedge, P1. Now with respect to wedge, acceleration of point 3 is A left, as it was for point 2. So A left, A3 is equal to A left and T3 is equal to T up. Angle is 90 degrees. So dot product becomes T into A into cos 0 degree, cos 90 degree, which is simply 0. So third term also I have written, okay. Plus T4 dot A4. T4 dot A4. Now what is T4 dot A4? T4 is which point? T4 is this point, yes, okay. Now what is T4 here? T4 is T down and A4 is acceleration of point 4 of pulley P2 with respect to wedge, which is again A left. So A4 is A left and T4 is T down. Angle between T4 and A4 is 90 degree. So again that product becomes 0. T into A into 0. The four terms we have dealt with. Now take this point 5. Now T5 is 0.5 T5 is just T left. And acceleration of 0.5 with respect to wedge is again A left. For same reason it was for 0.2. Okay. So this becomes T into A into cos 0 degree, which is simply TA. Cos 0 degree becomes plus 1. Alright. Now we take this this one. Pulley P3, 0.6. Now T6 is what? T rightward. And what is A6? Acceleration of 0.6 of pulley P3 with respect to wedge. But with respect to wedge, this pulley P3 is rest. So acceleration of 6 with respect to wedge is again 0. So T into 0 again becomes 0. T into 0. Okay. Now take this 0.7 here. T7 is T down. Okay. And acceleration of 0.7 is what? It is simply 0 with respect to wedge. So again it becomes T into 0. Okay. Lastly we are left with 0.8. At 0.8 T8 is T up and A8 is what? B down. Angle between T up and B down is 180 degree. Dot product becomes T into B into cos 180 degree. T into B into cos 180 degree is TB into minus 1. That is equal to 0. Fine. Alright. Now what I do, I rub this, okay. So what is the term which we get here? T, only see this T remains, this T remains and TB remains. Baki remaining 5 term go away. What do we get? 2TA minus TB is 0. Now T cancels out. B is equal to 2A. First relation we have obtained, okay. This is the first constraint relation which we have obtained. B is just equal to how much? 2A. Fine, alright. Now, what I'll do, first I'll rub it, okay. Now what I'll do, I'll draw the free body of wedge and block with respect to ground separately. Separate free bodies of block and wedge with respect to ground, okay. The FBD of wedge with respect to ground. FBD of, no, first we'll draw the block. So FBD of block B with respect to ground, G for ground, okay. So I'll draw the FBD of block B with respect to ground, okay. See, here it is Mg. Only real forces will act on this block because ground is taken to inertial frame. Tension T acts upward. This wedge will exert a normal force N1 on this block in upward direction. With respect to wedge, this block is moving downward with some acceleration B. So with respect to wedge, this block is slipping down. So the vertical face of this wedge will exert a friction force F1 on this block in upward direction. Okay. These are the only forces acting on the block B. Okay. Now what I do, here slipping is taking place, so F1 will return as what? Mu times N1. F1 is equal to how much? Mu times N1, that is F1. Alright. F1 is equal to mu times what? N1. Alright, fine. Now what we have to do? I'll draw the free body of 3m with respect to ground, okay? This is the block, FBD of block. Now I draw the FBD of 3m with respect to ground, okay? These are rabbits, I make it smaller so that they get more space. So I draw the FBD of 3m, see. 3mg. Now this pulley P3 is taken to be considered part of wedge. Pulley P3, okay, fine. I'll rub this one, okay, fine. This I draw to the second column, fine. See, FBD of wedge W with respect to ground, okay. What are the real forces acting? 3mg. A ground force will exert some normal force N2. With respect to ground, wedge is moving rightward, slipping rightward. So ground will exert a friction force F2 on wedge, F2. That is just equal to 2 mu times N2. F2 is equal to 2 mu, I'll write it later, okay. Then what are the other forces? Pulley is also part of this wedge, okay. Now what are the forces? Pulley effectively T here. As I've discussed just now in constraint theory, constraint relation. Then this block will exert a force N1 on the wedge in backward direction, Newton's third law. The wedge exerts a friction force F1 on block in upward direction. Block will exert a friction force F1 on the wedge in downward direction, Newton's third law. I hope it is clear. Fine. I think that's all. Fine. Alright. All the free bodies have been drawn. Now here slipping is taking place between ground and the wedge. So F2 is equal to friction coefficient into N2. Here friction coefficient is 2 mu. This becomes 2 mu into what? N2. F2 becomes 2 mu into what? N2. Okay. Fine. Alright. Now what I'll do? First I'll apply the Newton's second law to this block in the rightward direction with respect to ground. What do I write? In rightward direction I apply Newton's law to this block B. Only real force on block in rightward direction is N1. That is equals to mass times acceleration of this block B with respect to ground in this direction, which is simply just the rightward acceleration of wedge with respect to ground, A. Why so? Because both the bodies are rigid and mutual contact. So, and there are no rotation. So, acceleration of these two bodies, block and wedge in rightward direction, both are equal, A. If you want, we can derive this also. How can you, if we want it, we can derive it also. How to derive it? Suppose we take x to be rightward direction and y to be downward direction. I am deriving this A. This term I am deriving it, okay? Fine. So, what do we write now? I'll write like this. I'll write like this. See, N1 is equals to M times. What do we require here? X component of acceleration of block B with respect to ground. That becomes how much? ABGX. What I am doing, I am deriving this equation rigorously, okay? So N1 becomes M times ABGX is simply component of ABG along x-axis, unit vector along x-axis, which is I hat, dot with this. So this becomes M times ABG will return as what? ABW plus ABWG dot I hat. Now ABW is acceleration of block with respect to wedge, which is nothing but vector B, and AWG is acceleration of wedge with respect to ground, which is nothing but vector A dot I hat. This becomes B dot I hat plus A dot I hat. Now what is B dot I hat? B is in downward direction, I hat is in rightward direction. Angle is 90 degree between these two vectors. So dot product goes away. So this becomes 0. A dot I is simply A into 1 into cos 0 degree, which is simply A. That is just MA. Same equation which you obtained here directly also. Directly also wrote it and I proved it also. In case you have any doubt, you go to apply this method. Alright. So what do we get? N1 equal to MA. Fine. Alright. N1 is just equal to how much? MA. Alright. Now I love this equation. So N1 is equal to MA. Alright. N1 is just equal to how much? MA. Alright. Now, one relation we have obtained previously also we have obtained. What was that relation? B equal to 2A. This we have obtained. And one more relation we have obtained. N1 is equal to what? MA. And F1 is equal to mu N1. That is just equal to how much? Mu MA. Three equations which we have obtained here. Alright. Now I love this one. Now what I do, see, what I do next. Now what I do, I set up the combined equation of motion of block plus wedge in rightward direction. Okay. Now we have always set up the combined equation in ground frame. Only real forces will act. To be more precise, only real external forces will act on the system of block plus wedge. Only real external forces will act on the system of block plus wedge. So now what are the real external forces of the system block plus wedge? What are the real external forces of the system of block plus wedge? That we have to know. What are the real external forces on the system of block plus wedge? What are the real external forces on the system block plus wedge? This we have to tell. Okay. Now see, all the real forces on the block and wedge, they have been shown separately. Now see, what are the internal forces on the system wedge plus W? Internal forces are N1, internal force, because they are part of the system, exert on each other. F1 is also an internal force. This T and this T is all internal force. So what are the only external forces on the system wedge plus block? What are the external forces on the system wedge plus block? What are the external forces on the system wedge plus block? Okay. I'll just take a gap here. Okay, fine, I'll do this. Okay. So what I'm going to do now is that first I am going to set up the combined equation of motion of block plus wedge with respect to ground in rightward direction. Okay. So only real external forces appear. So what are the real external forces on the system block plus wedge? 3mg, mg, F2, N2, T, and this T here. These are the only external forces of the system block plus wedge. We are interested in external forces along rightward direction. So they are T plus T, 2T minus this F2. Okay, fine. So these are the only external forces of the system block plus wedge in rightward direction, in x direction. That is equals to summation of mass times acceleration of blocks of particles of the wedge. That is simply how much? 3 ma. Alright. Plus mass times acceleration of block with respect to ground in rightward direction, which is simply A, as I determined just now. When I set up this, when I calculated the horizontal acceleration of this block B, it was simply A rightward. Okay. So 2T minus F2 is equal to 3 ma plus ma. Alright, fine. So 2T minus F2 equal to how much? 4 ma. Alright. 2T minus F2 is equal to how much, tell me? 4 ma. Alright, fine. Now, what is F2? F2 is 2 mu N2. Okay. So, F2 is equal to 2 mu N2. Okay. Alright. Now, how to write this? Find this N2. Now, see, N2 is, for that to find N2, what I do, I consider the system wedge plus this pulley P3 and apply Newton's second law to this wedge with respect to ground in vertical direction. Okay, fine. So these are a bit now. So now free body of this wedge plus pulley has been drawn here. We apply Newton's second law to this wedge plus pulley P3 in downward direction, vertical direction with respect to ground. In vertical direction, its acceleration with respect to ground is 0. So net vertical force on this wedge plus pulley P3 is 0. This total upward force is equal to total downward force. The forces balance each other. What do you get here? Downward force is what? 3 mg plus T plus F1. 3 mg plus T plus F1. That is just equal to N2. Okay. N2 up 3 mg F1 and T. T F1 3 mg in downward direction. 3 mg plus T plus F1 is equal to N2. Now we also have to find F1, but F1 I have already written it down, mu times ma. So N2 becomes 3 mg plus T plus mu times ma. N1 was shown to be ma. So N2 is equal to 3 mg plus T plus mu ma. N2 has also been determined fully. Alright. So N2 becomes how much? 3 mg plus T plus mu ma. N2 is equal to 3 mg plus T plus kya? Mu ma. This is N2. Now what I do, I replace this F2 here, replace this N2 here, I get F2. Replace F2 here, I get the relation for combined equation I get. Okay. Now this I'll grab it. Okay. Fine. So what I get? See, 2t, okay, minus 2 mu into N2. N2 is how much? 3 mg plus T plus mu ma. Okay, fine. So 2t minus 2 mu into 3 mg plus T plus mu ma, that is just equal to 4 ma. Alright, fine. Is it alright? Now, what we have to do next now? See, we have to remove this t. Now we have to set up one more equation. Alright, now I rub this one, okay? So, 2t minus 2 mu into 3 mg plus T plus mu ma is equal to 4 ma. Now we have to find t also has to be removed, okay? Then only we get the value of a. Now how to find t? Now what I do, apply Newton's second law to this block with respect to ground in downward direction. Free body of this block of mass m has already been drawn. I'll just redraw it again for the sake of convenience. mg, t, n1 and f1. I apply Newton's second law to this block with respect to ground in downward direction. What do I write here? mg minus t minus f1. mg minus t minus f1 is equal to n times, what do I write here? I write the name of the term ABGY. ABGY meaning what? Y component of acceleration of block B with respect to ground. Now this can be written as n times ABG dot J hat, where J hat is a unit vector in downward direction. So this I write here as, mg minus t minus f1 is just mu times n1. N1 has been shown to be ma. So F1 becomes mu ma. Now ABGY will be written as ABG dot J hat. ABG will be written as, from translating frame formula, it will be written as ABW plus AWG dot J hat. I hope it is clear. Fine. Okay, fine. I rub this one now. So this becomes this. I write it here, see. So mg minus t minus mu ma n times ABW is nothing but vector B, acceleration of block B with respect to wedge, which is B down, and AWG is nothing but vector A dot j hat. mg minus t minus mu ma B dot j becomes 0. Sorry, B dot j becomes B into 1 into cos 0 degree. A dot j becomes 0 because they are mutually perpendicular. Dot product two mutually perpendicular vectors is 0. That term goes away. So we get T is equal to mg minus mu ma minus mb. Now b is equal to 2a, as we have determined in the beginning of this problem. This becomes mg minus mu ma minus 2ma. This is T. Okay. Now this T, what I'll do is substitute in this combined equation. I'll get the required answer. Fine. Alright. Now I rub this one. I rub all this. Okay. Fine. So T is equal to mg minus mu ma minus 2ma. Now this T I substitute in this equation. First what I do is simplify it still both. T is common here, T is common here. Okay. I have to remove this 2 first. 2 goes away. 2 is a common term. Minus mu plus T plus mu ma barabar 2ma. 2 goes away. Now I take T common. T into 1 minus mu minus 3 mu mg minus mu square ma is equal to 2ma. Alright. Now this T I substitute here. Alright. T is equal to mg minus T is this T I substitute here now. Now what I do, I rub this first two equations to get more space. So now T is how much? Now this T I substitute here. T is equal to mg minus mu ma minus 2mb. So this T I substitute here. mg minus mu ma minus 2ma into 1 minus mu minus 3 mu mg minus mu square ma is equal to 2ma. Alright. Now m goes away, m is a common term, it cancels out. Okay, fine. Alright. So I'll move this equation now. I'll simplify this equation. I cross multiply it. G into 1 minus mu g minus mu g minus mu a into 1 minus mu a minus mu a into minus mu becomes mu square a minus 2a plus 2 mu a minus 3 mu g minus mu square a barabar 2a. Mu square term cancels out. What do we get? 3 mu g and mu g, 4 mu g. G into 1 minus 4 mu. This term has been dealt with, this term has been dealt, this also term has been dealt with. Now we are left with how many terms? 2a goes that side. So that means 2a plus 2a. Alright. And what about this? Mu a minus mu a, simply plus mu a, it goes that side. So minus mu a. Alright, fine. I rub this one, okay? So what do we get here? G into 1 minus 4 mu A into 4 minus mu. So A becomes G into 1 minus 4 mu by 4 minus mu is therefore the required answer to this problem. Okay, so A is equal to G times 1 minus 4 mu by 4 minus mu is therefore the required acceleration of wedge with respect to ground after the system is released from rest. I hope it is perfectly clear. Okay, this is therefore the required answer. So just I'll summarize it once again. Okay, what are the steps which I followed? First I drew the diagram, I stated the problem. Okay, then I showed the acceleration of two bodies. Okay, then I proved that stated that tension at all points of string is same, equal to T say. Alright, then I found the relation between A and B using a detailed method. T1 dot A1 plus T2 dot A2 and so on add up to 0. Okay, and explain all the necessary theory behind it. Okay, then what I do, I drew the free body of block and wedge in with respect to ground. Okay, then I apply Newton's second law to the combined equation of motion I wrote down for the block and wedge in rightward direction, and I apply Newton's second law to wedge in separately in vertical direction, and I apply Newton's second law to the block in both rightward and vertical direction with respect to ground, and I solve the resulting equations to obtain the required answer. This is therefore the required answer. Okay, so this is therefore the acceleration of wedge with respect to ground after the system is released from rest. Okay, so go through it properly. In case you have some doubt, you write it in the comment box. I'll explain it. Alright, so now I'll finish it here.